Welcome to godot4. In this lesson, we will build a small 2D game loop called Skyline Courier. The player moves through a compact city, collects delivery packages, and sees the score change. Godot is a scene-based engine, so our project will grow from reusable scenes and a tree of nodes. Its 2D toolset includes a dedicated renderer, physics, animation, particles, and tile-based level tools. We will stay focused on the fundamentals that transfer to platformers, top-down games, and puzzle games. By the end, you should be able to create a project, assemble a player, map input, detect interactions, build a simple level, and test and export. Treat each chapter as a small experiment. Run often, change one thing at a time, and keep the project in version control from the first saved scene. Start with the project itself. Download a current stable Godot release from the official Godot website, then create a new project in an empty folder. For a simple 2D lesson, the compatibility renderer is a sensible default when broad hardware support matters, although you can choose another renderer when a project needs its specific features. Open the editor and notice the 4 places you will use constantly: the scene dock, the inspector, the file system dock, and the main viewport. Save a root scene as main.tscn and set it as the project main scene so F5 always launches the same starting point. Godot uses the res:// for project files and imports supported assets automatically. Before building, open project settings and create named input actions. These actions keep gameplay code independent from physical keys and make later controller support much easier. A clean project is not bureaucracy. It is a fast feedback loop. Think of nodes as capabilities and scenes as reusable assemblies. A node 2D can provide a transform. A sprite 2D can draw an image. A collision shape 2D can define a boundary. A camera 2D can follow a subject. Put those nodes under a root that describes the object's job, then save the branch as a scene. Our main scene owns the level and game flow. Our player scene owns the character's visual, collision shape, and movement script. When main instances player, the player becomes one reusable object in the larger tree. This separation prevents one giant script from knowing every detail of every object. Godot's best practice guidance also encourages focused scenes with loose coupling. Let a child scene keep its own implementation details, and communicate across boundaries with public methods or signals. If you can test player on its own, before the whole level exists, you are building a project that is easier to debug and easier to reuse. Now build the player scene. Choose character body 2D as the root when the character is controlled by code and needs collision-aware movement. Add a sprite 2D, or an animated sprite 2D when you already have frame-based animations, then add a collision shape 2D as a child. The sprite is what the player sees. The collision shape is the simple geometry the physics engine uses. Size the shape to match the body, not every transparent pixel of the artwork. Attach a script to character body 2D and expose a speed variable so it can be tuned in the inspector. Character body 2D is not pushed around by physics automatically. Your script sets its velocity and asks it to move. For platformers, you can use gravity and floor checks. For a top-down game like ours, a 2-dimensional input vector is enough. Keep the player scene self-contained, save it as player.tscn, and test it as a scene before you place several instances inside the city. Input should describe intent, not hardware. In project settings, open input map and create move left, move right, move up, and move down. Bind arrows and WASD to those actions, and add a gamepad later without rewriting the movement script. On the player, read the actions with input.getVector. It returns a direction whose length is limited, so diagonal movement does not become accidentally faster. Multiply that direction by speed and assign the result to velocity. Then call move and slide inside physics process. Character body 2D uses the physics steps delta internally for this method, so do not multiply velocity by delta first. That common mistake turns a speed into a tiny movement vector. When the player is idle, set velocity to 0 through the same input calculation. This gives you one predictable path for keyboard, controller, and remapped controls. Run the scene, watch the player move, and tune speed only after the collision shape and input actions are working. Interactions are easiest to maintain when objects announce what happened. Create a package scene with an area 2D root, a sprite 2D child, and a collision shape 2D child. Area 2D detects bodies entering its region but does not physically block them. Connect its body entered signal in the editor or in code. When the player enters, check that the body is the expected character, emit a collected signal, and remove or hide the package. The main game scene can listen for collected and increase the score without reaching into the package's private details. This is the important idea behind signals. The sender reports an event and the receiver decides what to do. The same pattern works for doors, damage zones, buttons, timers, and enemy defeats. Use collision layers and masks deliberately because they decide who can see whom. If an overlap never fires, inspect the shapes first, then check the layer and mask settings before changing code. Build the level from pieces you can read. Use Node 2D containers for background, obstacles, pickups, and actors. For tile-based environments, create a tile set resource and use the tile tools available in your godot4 release. Some releases expose tile map layer alongside older tile map workflows, so follow the node type recommended by the editor you installed. Put collision data on the tiles or use static body 2D shapes for walls that must stop the player. Keep the playable area larger than the camera view, then make camera 2D a child of player, so the view follows movement. Instance the player scene once and place several package scenes in reachable positions. The scene tree should tell the story of the game at a glance: main, world, player, packages, and HUD. Avoid deeply nested paths that every script must memorize. If a scene needs another object, pass a reference, call a method, or use a signal rather than relying on fragile global lookups. Add feedback with a HUD that follows the screen instead of the world. Create a canvas layer under main, then place control and label nodes beneath it. Canvas layer keeps the interface fixed while camera 2D pans through the city. Give the score label a clear starting value, and update it when main receives the package collected signal. A tiny amount of state is enough for this prototype: a score integer, a start or game over state, and the current scene. When the game grows, keep responsibilities separate. The player handles movement, packages report collection, main owns the rules, and the HUD displays the result. For menus or restart button, use control signals and change scenes through the scene tree instead of hard-coding a web of node paths. Test the layout at the window sizes you plan to support. Anchors and containers are usually more resilient than manually positioning every label. A readable HUD teaches the player what the game considers important. Polish comes from short test cycles, not from adding everything at once. Use F6 to run the current scene and F5 to run the project main scene. When something fails, read the debugger message before changing code. The remote scene tree shows the nodes that actually exist while the game is running. Turn on visible collision shapes when a body seems to pass through a wall or an area 2D never detects the player. Add breakpoints to inspect values such as velocity, score, and the body received by a signal. Once the loop works, improve one layer at a time. Use animated sprite 2D for movement states, add a camera 2D limit, use animation player for a pickup pulse, and add particles or sound only where they clarify an event. For pixel art, choose consistent texture filtering and scale rules. Keep the design legible at normal play speed. The best beginner project is small enough to finish and specific enough to teach you what to build next. Before sharing the game, make the project easy for another person to open. Keep assets near the scenes that use them, use Pascal case for node names, and use snake case for GD script variables and functions. Keep reusable scenes focused and avoid putting every system in main. Confirm the main scene, input actions, window size, stretch settings, and audio buses. Then open project, export and create a preset for the target platform. Run the exported build, not only the editor version. Check movement, collisions, the score, restart flow, and any files loaded at runtime. Our godot4 2D workflow is now a complete loop. Scenes describe structure, nodes provide capabilities, scripts handle behavior, input map translates intent, physics moves bodies, signals connect events, and the HUD communicates state. From here, choose one upgrade: animation, tile art, sound, enemies, menus, or a save system. Build the next small loop, test it early, and keep learning from the official documentation.